This topic is about being able to use the derivative to determine whether a function is increasing or decreasing in a given interval. So a function is increasing when y values increase as x values increase. So if we were to draw a diagram, this is x, this is y, then the function does something like this. Let's say this point is x1 and this point is x2. This is y is equal to f of x. Then this would be f of x1 and this is f of x2. You can generally see that y is equal to f of x is going up as you go along the graph. So we say y is equal to f of x is increasing when x1 is less than x2, then f of x1 is less than or equal to f of x2. So basically, it's allowed to be equal as well. Now, y is equal to f of x is strictly increasing when x1 is less than x2, then it's a strict inequality. So f of x1 is less than f of x2. You can also see that the gradient is always, don't like the first, undo. What I don't like is this part, oops. So let's draw it again. Okay, so it's generally increasing. But the gradient, you can see the gradient is always positive. So in these cases, f dash of x is greater than or equal to 0 for all values of x. So if I were to write it properly, it's greater than or equal to 0. Okay, obviously it's greater than 0 if it's a strictly increasing. Now in a similar way, for a decreasing function, a function is decreasing when y values decrease as x values increase. So if I were to sketch this out, then you have x here and then you have y here, then that means it's generally the graph is going downhill. So that means if you have a point on the curve, y is equal to f of x, this is x1, and this is x2, then this is f of x1, and this is f of x2. So you can see the y value is decreasing as the x value increases. You can see from the graph that y equals f of x tends to go down as you go along the curve. Okay, now we say y is equal to f of x is decreasing when x1 is less than x2, then f of x1 is greater than or equal to f of x2. Y is equal to f of x is strictly decreasing when x1 is less than x2, then f of x1 is just greater than f of x2. tangent at any point on the curve y equals f of x, we can see that the gradient is always negative. So f dash of x is less than or equal to 0 for all values of x. And obviously, if it's strictly decreasing, then it will be less than 0. So this is everything that is summarized about increasing and decreasing functions. Okay, so definition recap. The function f of x is increasing on the interval a and b, so it doesn't have to be increasing throughout the whole graph, so it can be between the interval a and b if f dash of x is greater than or equal to 0 for all values of x, such that a is less than x is less than b. Okay, and the function f of x is decreasing on the interval ab if f dash of x is less than or equal to 0 for all x's, for all values of x, such that a is less than x, which is less than b. So if you look at this first example, you can see f of x is equal to x cubed plus x is increasing throughout everywhere, yeah? Throughout the whole graph. So you can say it's increasing for all x is an element of reals, so all real numbers. If you see, look at the second example, you can see the function f of x is equal to x to the power of 4 minus 2x squared is increasing. So if I wanted to find an interval where it's increasing, I can see clearly between x equals minus 1 and x equals 0 is increasing. So it's increasing on the interval from minus 1 to 0. So I can say it's increasing because you can see it's going up there, so it's positive there. But I can also say f of x is equal to x to the power of 4 minus 2x squared is decreasing. So if I look at the point where it's going down, from 0 to minus 1, you can see it's going down, so it's decreasing. So it's decreasing on the interval 0 to x equals 1. So what we do know is that a function can be increasing in some intervals and decreasing in other intervals. So the whole function does not always have to do the same thing throughout. Just a word of warning, if you have something that's a note, so if you have something that is a is less than x, which is less than b, then that is represented by rounded. So because a and b are not included in this inequality, then x is the element of a, b. Okay, but if we have a is less than or equal to x, which is less than or equal to b, so we include an a and b, then we use square brackets. So if I have something like this, a is less than x, which is less than or equal to b, then it's the same thing as writing a is not included, so we do a rounded bracket, oops, a, and then b is included, so we do a square bracket for the ending. Let's go through some examples now. So apply the theory that we've just learnt. Show that the function f of x equals x cubed plus 24x plus 3 is increasing for all values of x. If it's increasing implies f dash of x is greater than or equal to 0 for all x is an element of real. So that's what we need to prove. So first thing I need to do is work out f dash of x. So f dash of x is equal to 3x squared plus 24. Now we know all square numbers are greater than or equal to 0. So since x squared is always greater than 0 for all x is an element of reals, then 3 lots of x squared would also be greater than or equal to 0 for all x is an element of reals. That means 3x squared plus 24 will always be greater than or equal to 24 for all x is an element of reals. But that means if it's greater than or equal to 24, then that means 3x squared plus 24 is definitely greater than or equal to 0, because it's always 24 or more. So for all x is an element of reals. Therefore, we know that f of x is increasing, because it's always greater. The gradient function is always greater than or equal to 0. Increasing for all x is an element of reals. So that would be my conclusions. Okay, next example. Find the interval on which the function f of x is equal to x cubed plus 3x minus 9x is decreasing. So decreasing means f dash of x, f of x is decreasing. F of x is decreasing implies f dash of x is less than or equal to 0. The first thing I need to do is work out the derivative of f of x. So that means I get 3x squared plus 6x minus 9. And I can factor out the 3, so I get x squared plus 2x take away 3. If I factorize that bracket, I get 3 times x plus 3 times x minus 1. So if I were to sketch this out, because we're looking for when f dash of x is less than or equal to 0, which implies 3 times x plus 3 times x minus 1 is less than or equal to 0, then if I sketch out this, then that means this goes through 1 and negative 3. It's a positive quadratic, so it goes through, it looks like this. We don't care about the y value. So we're looking for when it's less than or equal to 0, which means we're looking at this part. So that means minus 3 is less than or equal to x, which is less than or equal to 1. So f dash of x is less than or equal to 0 when minus 3 is less than or equal to x, which is less than or equal to 1. Therefore, f dash of x is f of x, not f dash of x. F of x is decreasing on the interval minus 3 to 1. Okay, find the values of x for which f of x is an increasing function given that f of x equals these ones. Okay, so the best thing to do is go through all the examples. So let's do a first. So first thing I need to do is, remember we're looking at for when it's an increasing function. So f dash of x, always work out the gradient. So it's going to be 3 minus 6x plus 3x squared. So if I factorize it out, I get 3 times x squared minus 2x plus 1, which is equal to 3. Factorize it gives me x minus 1 times x minus 1, which is equal to 3 times x minus 1 squared. So if f of x is increasing, implies f dash of x is greater than or equal to 0. So when is this greater than or equal to 0? 3 times x minus 1 squared is always greater than or equal to 0, because x minus 1 squared, which is a square number, is always greater than or equal to 0. Therefore, 3 times x minus 1 squared is greater than or equal to 0. Therefore, f of x is increasing for all x is an element of reals. Let's do b. So b, f dash of x is equal to 15x squared plus 12. So when f of x is increasing, implies f dash of x is greater than or equal to 0. So we need to know when this is equal to 0. Again, x squared is greater than or equal to 0 for all x is an element of reals. Therefore, 15x squared is greater than or equal to 0 for all x is an element of reals, which implies 15x squared plus 12 is greater than or equal to 12 for all x is an element of reals, which implies 15x squared plus 12 is greater than or equal to 0, because if it's greater than or equal to 12, it's always greater than or equal to 0 for all x is an element of real. Therefore, f of x is increasing for all x is an element of reals. The last one, which is c. f dash of x is equal to 4x cubed plus 4x, which is equal to 4x times x squared plus 1. If I were to sketch this out, then now know x equals 0 is it's a cubic, obviously, so it's a positive cubic, so it goes from quadrant 3 to 1. X equals 0 is a root, and there is no other real root, so it's only going to have one x-intercept. It's going to go something like that. So if it's f of x is increasing, it implies f dash of x is greater than or equal to 0. So when is this graph greater than or equal to 0? So when is 4x, so which means 4x times x squared plus 1 is greater than or equal to 0. So when is that greater than or equal to 0? It's greater than or equal to 0 for this part of the graph. So everything from then onwards, which means x when x is greater than or equal to 0. So therefore, f of x is increasing for x greater than or equal to 0. Okay, for these ones, find the values of x for which f of x is a decreasing function now. So it's decreasing now. Okay, let's go through each one individually. So f dash of x will be equal to minus 27 plus 3x squared. F of x is decreasing, implies f dash of x is less than or equal to 0, which means minus 27 plus 3x squared is less than or equal to 0, which means 3 times x squared minus 9, if I factor the 3 out, is less than or equal to 0, which means 3 times x minus 3 times x plus 3 is less than or equal to 0. So if I sketch this out, so it's a quadratic minus 3 and 3. I'm looking for where it's less than or equal to 0. It's between there and there. So it implies x is between minus 3 and 3. Therefore, f of x is decreasing on the interval minus 3 to 3. Mr. Bina. Okay, so f of x, if we were to rewrite it, f of x is equal to x plus 25x to the minus 1 in index form. F dash of x will be equal to 1 minus 25 x to the minus 2. Now, the important thing here is that you need to know, because it's 25 over x, x cannot be equal to 0, because we can't have 0 in the denominator. So that's an important thing that you should write down. Okay, that means, remember, f of x is decreasing, which implies f dash of x is less than or equal to 0, which means we need to solve 1 minus 25x to the minus 2 is less than or equal to 0, which is the same thing as solving 1 minus 25 over x squared is less than or equal to 0 like this, which means x squared minus 25 is less than or equal to 0. Factorize this, we get x minus 5 times x plus 5 is less than or equal to 0. So if you sketch it, you've got minus 5 to 5. It's a positive quadratic. You're looking for the part that's less than or equal to 0. So it's between minus 5 and 5. But don't forget it's undefined at x equals 0. So that means it implies for all x is an element of minus 5 to 5, but x cannot be equal to 0. Which means if I were to write it out, therefore f of x is decreasing on the interval. So it's going to be two separate parts, from minus 5 to 0, but not including 0, and 0, but not including 0, to 5, but including 5. So it's going to be two separate parts, because remember there's a point missing. The 0 cannot be included. Okay, C. Okay, f dash of x first is equal to half x to the minus a half. Again here, in this case, x is not equal to 0. Because we've got x to the minus a half, which means x is the denominator, x cannot be equal to 0. So half x to the minus a half, minus, when you differentiate it, you get minus 9 over 2 x to the minus 3 over 2, which is, again, because f of x is decreasing, which implies f dash of x is less than or equal to 0. So we've got half x to the minus a half minus 9 over 2 x to the minus 3 over 2 is less than or equal to 0. If I multiply both sides by x to the power of 3 over 2, so times by x to the power of 3 over 2, then I get half x minus 9 over 2 is less than or equal to 0. If I multiply through by 2, I get x minus 9 is less than or equal to 0. And x must be less than or equal to 9. So if I go back to the original function, because it means x to the half means square root of x plus 9 over square root of x. X can also not be negative, so x has to be greater than 0. So x has to be, cannot be 0, but also cannot be less than 0 because we're taking square roots. So that means, therefore, x is between 0 and 9. So therefore, f of x is decreasing on the interval. So we don't want to include 0, but we do want to include 9. That is it. The last one is d. So d, if I expand it, I get x cubed plus 3x squared. So f dash of x is equal to 3x squared plus 6x. F of x is decreasing, implies f dash of x is less than or equal to 0, which means 3x squared plus 6x is less than or equal to 0, which means 3x times x plus 2 is less than or equal to 0. So if I sketch it out, it's a positive quadratic going through 0 and negative 2. So I'm looking for it, it's less than or equal to 0 is between here and here. X is between minus 2 and 0. Therefore, f of x is decreasing on the interval minus 2 to 0. Show that the function f of x is equal to 4 minus x times 2x squared plus 3 is decreasing for all x elements of 0. So I'm going to rewrite f of x as f of x is equal to, expand the bracket out, so I get minus 2x cubed minus 3x. So f dash of x is equal to minus 6x squared, take away 3. Now, since x squared is greater than or equal to 0 for all x is the element of real, that implies minus 6x squared is less than or equal to 0 because we're multiplying by minus 6 for all x is the element of reals, which implies minus 6x squared take away 3 is less than or equal to negative 3 for all x is the element of reals. But that also implies that minus 6x squared minus 3, because it's less than or equal to negative 3, is definitely less than or equal to 0 for all x is the element of reals. Since f dash of x is less than or equal to 0 for all x is the element of reals, f is decreasing for all x is the element of reals. Okay, so part A, given that the function f of x is equal to x squared plus px is increasing on the interval minus 1 to 1, find one possible value of p. Okay, if it's increasing to A, first thing I need to do is f dash of x, which is equal to 2x plus p. Since f of x is increasing, this implies that f dash of x is increasing in the interval, so I need to include that. Increasing on the interval minus 1 to 1. This implies f dash of x is greater than or equal to 0 for all x between minus 1 and 1. This implies 2x plus p, because this is the f dash, I found that to be the expression for f dash of x, but is greater than or equal to 0 for all x is the element of minus 1 to 1. Okay? When x equals negative 1, 2x plus p is greater than or equal to 0 becomes minus 2 plus p is greater than or equal to 0, which implies p is greater than or equal to 2. When x is equal to 1, 2x plus p is greater than or equal, 2x plus p is greater or equal to 0 becomes 2 plus p is greater than or equal to 0, which implies p is greater than or equal to negative 2. If p is greater than or equal to 2 and p is greater than or equal to negative 2, it implies p must always be greater than or equal to 2. One possible value for p is 2. B. State with justification whether this is the only possible value for p. No, as p is greater than or equal to 2. Therefore, p is 2, 3, 4, so on. It can be more than one value. Any value of p where p is greater than or equal to 2 will work. Last question. The function f defined for x as the element of real x is greater than 0 is such that f dash of x is equal to that. Find the value of f double dash of x. Now f dash of x is a second derivative of x, so you differentiate again. So f double dash of x is x squared differentiates to 2x, minus 2 differentiates to nothing. 1 over x squared, if I were to rewrite this, is the same thing as x to the minus 2. So x to the minus 2 differentiates to minus 2, x to the minus 3. If I want to find the second derivative, f double dash of 4, all I need to do is substitute 4 in there. So that's going to be 8. 2 times 4 is 8. 4 cubed is 64. So the same thing as 2 over 64, which is equal to 1 over 32. So 8 take away 1 over 32 is 7, and 31 over 32. B. Prove that f is an increasing function. To prove f is an increasing function, I have to show that f dash of x is greater than or equal to 0. Okay, so I need to show, to prove that f is increasing implies f double dash of x is greater than or equal to 0. So what I'm trying to show is x squared minus 2 plus 1 over x squared is greater than or equal to 0 for which values of x. Then I need to show that if I multiply through by x squared, I get x to the power 4 minus 2x squared plus 1 is greater than or equal to 0. I can see that that becomes x squared minus 1 times x squared minus 1, which is greater than or equal to 0, which means x squared minus 1 squared is greater than or equal to 0. Now, all square numbers are greater than or equal to 0. Therefore, x squared minus 1 squared is always going to be greater than or equal to 0 for all x is the element of reals. X is greater than 0 because that's where it's defined. Therefore, f is increasing Let's try again. Therefore, f is increasing for all x is the element of reals. X is greater than 0.